Testing, 1, 2, 3. Oh boy. Well, this is new. I usually don't have problems like this. You are admitted. And no wait. Testing. Bingo. All right. Weird.
Wait, so I got switched to Tuesday and Thursday,
Heck yeah, you did.
and it's Wednesday.
Yep.
So should I like not be here now?
Okay. If somebody comes here and wants to like take your seat, what we're gonna do is I'm gonna have you.
I have my AirPods and I can do the Zoom on my phone.
No. I have a solution. What's gonna happen is if somebody comes in here and wants that chair, I'm gonna have you and that person go out in the front lawn. You're gonna wrestle for it, and whoever wins gets to stay. No. We've got open seats, so I'm not really gonna worry about it. That reminds me though. Let's get going on attendance. And what's the best way to do this? Let's go to docs. Por favor. The good news is we don't actually have that much to cover today, so I can actually waste time doing this. And it's actually not even that big a deal. Because today, if you're curious what we're doing today, so I like to go through about homework a lecture. You guys might have noticed that Monday was primarily a homework 6 kind of day. Should probably put the shield on. Because again, if I get sick and I'm not wearing this, y'all might get sick because I'm basically yelling. This is for you, not for me. Because I don't want you to die because of me. Miraculous. Oh, great. You guys get to really see my terrible handwriting today. Ooh. What was I gonna say? Okay, so fun fact, people are getting quarantined, including some people that are members of this class. That's fine, it's great. But that's also happening in some of your other classes. So I don't know if somebody's actually sat down and explained this to you, so I'm going to explain it to you. If, hypothetically, let's say I get sick. All of you have to be quarantined because you interact with me twice a week, every single week. So because of that long interaction, it's a 15-minute interaction. We are in the same room as each other for longer than 15 minutes. NMU says, if I test positive, y'all have to quarantine. Your friends and everybody in your dorm doesn't have to quarantine, but you have to quarantine, along with anybody in my grad classes. So all my graduate student people and my one professor has to quarantine. Their classmates and their other stuff don't have to, but they just do. Now, let's say, I'm terrible with names. What's your name? Jared. Okay, let's say Jared tests positive for COVID. Not to pick on you. I'm just literally grabbing a person. If Jared tests positive, okay, y'all that are in here for longer than 15 minutes with him, y'all have to quarantine. And everybody in every single one of his classes has to quarantine. And everybody in his dorm floor, I believe, has to quarantine. That's how it rolls, because that way we just shut everybody down. Nobody moves until we figure out who's positive, who's not. That is the protocol. So again, nobody in this class has tested positive that I'm aware of. If you have, I'd like to know that. But that is just the protocol. Again, I don't know if somebody's actually sat down and explained this to you. Is this new information for y'all? Is this, you've heard this before? This is new. This is new for some of you. That's gosh darn awful. This should not be new information. You should know how this works. Oh man, that's so northern. Okay. Okay, so if you're wondering, trying to think. I could take attendance now, or I could do math now and take attendance later. Let's do that, because I'd rather do the fun stuff now. And yes, I'm not much of a nerd. I consider the math fun stuff. Okay, and heck yeah, we got math. All right. Anybody else? These are a couple questions somebody wanted me to do from the homework, wanted me to talk about. I think they're great to talk about. I'm happy to talk about them. Does anybody have any other questions from the homework at the top of their minds right now? Homework 6, homework 7 is kind of what we've done so far this week. Today is going to be here's a couple questions I'm going to answer, and let's talk about the stuff that's on your homework 8. That's going to be kind of what we do today. And if you had to title what today's notes are going to be, rational expressions and domains. That's what we're doing today. Not necessarily in that order. Okay, I'm not seeing many questioning eyes, so I think we're just going to go right for it. Okay, so this question was also given with not simplify, but factor. And I'm guessing completely.
Can you share your screen?
Every single day. I will get better. Okay. Y'all want to see paint? Yeah, Lego. Okay, so 64y squared minus 48y plus 9. Okay, we're told to factor it, but there's not a common factor we can rip out of everybody, right? 9 is made up of 2 3s, right? It's 3 times 3. 64 is 8 times 8. There's nothing really in common between 64 and 9. So there's not a common number we can rip out, and there's not a common variable we can rip out of everybody. So there's no common factors right off the bat. So that's the first thing we check. Nothing doing. So now, I think this is just going to be a good old trinomial thing. So if that's the case, we have a method for this. Let's AC this thing. So AC is going to be 64 times 9. That's absolutely disgusting, but we're going to do it. And ye old calculator. Okay, 64 times 9. 576. Oh yeah, that's a great little number right there. Okay, now here's the thing. This is a plus, right? So we have a plus. So I know they're both going to be the same, right? So I know I'm going to have some amount of y, some amount of y, and the signs in the middle are going to be the same. And this minus here tells me they're both going to be minus. So it's going to be something y minus times something y minus. Right, that could be 8y minus something times 8y minus something, or it could be some other combination. I'm not there yet, but I'm just kind of game planning right now. The main thing though is between my factors of my AC, so like 576 and 1, when we're looking at the two factors, because this is a plus up here, I know that these need to add in order to be 48. So we need two numbers that are factors of 576 that add up to be 48. Now, there's a whole bunch of things that go into 576. Good news is, I know that it's actually 24 squared. So 24 times 24 makes 576. Because some little computer chip in my brain told me that. And these things add up to be 48. So I'm actually going to erase this for a hot sec, because we don't need it. Because the first thing I'm going to do is anytime you have a number that is, no, not the eraser, get back. Anytime you have a number that is not a 1 in front of your leading term there, you need to do the break apart the middle with your AC numbers and then do factor by grouping. So that's exactly what we're going to do right now. So we're going to have 64y squared minus 24y minus 24y and then plus 9. And now, just like yesterday, we're going to split this down the middle. We're going to look at each side independently. Now, what do we have going? Let's do green. Okay, there's an 8 and there's a y in both of these. So we can rip that out. And we're left with 8y minus 3. Okay, there's a 3 in both of these, and honestly, not much else. Now, here's the thing. Remember, I said yesterday, if you have a negative here, always rip that bad boy out too. So we're going to rip out a negative 3, and then we're left with 8y minus 3. Because negative 3 times 3 gives you your positive 9 that you had. Okay. So now I have 8y somethings minus 3 somethings. So I have 8y minus 3 somethings. Okay. And the best part is we can actually simplify this. It's 2 of the same darn thing multiplied. So I can just go ahead and write this final answer, 8y minus 3 squared. All right, questions about the process. You do not, for the record, have to know that 576 is 24 squared off the top of your head. I do not expect you to know that. I actually did not expect myself to know that. That just kind of popped into my head. So a lot of times that AC, in order to get the two numbers, you're gonna have to do a lot more work to like break apart that 576 and see what actually gets you your middle term that you want. But totally doable, totally doable. Questions, comments? Okay. So let's go ahead and keep this train rolling. Okay. I talked about this problem with a couple of students. 2 ways to do it. There's the way WebAssign wants you to do it, and then there's the brute force method. And yes, brute force is very much a thing in math, if you were not aware. The thing that WebAssign wants you to see is that this is effectively a squared minus b squared. Difference of 2 perfect squares, just what we were talking about on Monday. You have something squared. In this case, it's a whole chunk. It's x squared plus 8 minus something squared. And that something is 36x squared. So you could hypothetically go ahead and call this. You could look and say a equals x squared plus 8. B equals the square root of 36x squared. So square root the 36 and you get 6. Square root the x squared and you get x. And then you can just go ahead and do what you always do with these problems. And you get a plus b, a minus b. And in this case, when we plug in what we have for a and b, when we just plug and chug, we get x squared plus 8 plus 6x times x squared plus 8 minus 6x. Now, here's where the people at WebAssign get really stinky. There's more we can do here. So if I rewrite these in standard form, where it's going like the highest power of x and it works its way down, you might notice a pattern here. So plus 6x plus 8, x squared minus 6x plus 8. You can actually factor these. We have 2 trinomials we can factor. And again, you can think about this with AC method. If we look at this critter, x squared plus 6x plus 8, what are factors of 8? Well, we either have 1 and 8, or we have 2 and 4. 2 and 4 is going to get the job done. And because there's a 1 in front of this, I'm done. I don't need to do the factor by grouping trick. So I can just go straight for, this is x plus 2, x plus 4. Yeah, I know they're plus because this tells me they're the same. And this tells me they're both plus. And here's the best part. We get the same darn thing on the other side. Because we get plus, the only difference is, so I know they're both the same, the only difference is they're both going to be negative. So from this term, so we get those two from the left term. From the right term, we're going to get x minus 2 and x minus 4. That's the final answer WebAssign would like you to arrive at. So, just on this method, questions, comments, concerns. I'm going to do it another way right now, too.
Does it matter which number is in front, like the 4 or the 2?
I don't care. I don't think WebAssign cares either. It's all multiplication, so it can all hypothetically go in any order. So, because, 2 times 3 is the same thing as 3 times 2. Still get 6 either way. So, I don't know if WebAssign feels the same way. I don't know if WebAssign has a preference on what order you do it, but I don't care. If it was an exam, right, if I'm grading it, if it's a written assignment, I'm not going to care what order you write them. Now, the other thing WebAssign did not count on, but some people actually went ahead and did it, just go ahead and FOIL that thing. Just go ahead and FOIL this, no, not the eraser, this x squared plus 8. Go ahead and FOIL that thing, because you have something squared. Okay, let's do it. So if you have x squared plus 8 times x squared plus 8, you're going to get x to the 4th plus 8x squared plus another 8x squared plus 64. And these middle 8x squareds, they can combine. You get plus 16x squared. And then from over here, we have minus 36x squared. So if we want to go ahead and put like terms together, you have a 16x squared, you have a minus 36x squared. So they're both x squared, so you can actually smash those together with subtraction. And what we're going to get is we're going to get, didn't note that this is a separate endeavor. So we're going to get x to the 4th minus 20x squared plus 64. Okay, now I know it's not x squared x constant, but actually it's basically kind of like that though. You have a constant, you have some amount of x, and then you have that amount of x to like double the exponent. So actually this is still a trinomial that we can factor using the AC method. So with the AC method, if we're looking at 64, so 64, you get 8 and 8, and you get 16 and 4. Those are the two big ones that we look at when we look at 64. Hey, this is a plus, so I know they need to add to make 20. How about that, 16 and 4? So you can actually get x squared minus 16 minus, because this sign tells us they are, and then x squared minus 4. Now, here's where I get my Billy Mays on and say, well, wait, there's more. These two terms are both differences of squares. So we can break these apart. And when we do, we get x plus 4, x minus 4, 4 being the square root of 16 here. And then we get x plus 2, x minus 2. Huh, that looks familiar. So no matter which way you do it, you're going to get the right answer as long as you do everything right. Now, on an exam, I might actually tell you, do this problem two ways. Do it by foiling first, and then factoring the trinomial. And I might tell you the other way to do it is to start off by doing difference of perfect squares, and then factoring trinomials. That is actually something I could say, but I would tell you that. If you need to do it a certain way, I will tell you. I will not just like try to like have you mind read me and figure out which way you're supposed to do it. That's stupid. Some professors do that though, where they like say, do this problem. And if you don't do it the way they want you to, 0 points. That's silly. I might just give you a problem and say, go for it, just factor. I don't care how. That's actually what I'm more liable to do, is I'm more liable to give you a problem and say, get her done, I don't care how. Because actually you may have watched this method and been like, yay, this is great. Or you may have looked at this and been like, no, this is terrible. I like this method more. So everybody has their own preferences. And quite honestly, I'm terrible at guessing who likes which. So if you need to do it a certain way, I'll tell you. If you don't need to do it a certain way, I'll just tell you, get her done. Questions about either method or how I test math. I was the same way in stats too. When I taught stats last semester, really didn't care how people got done as long as everything was legal.
So the first two parentheses in orange, those are for.
Yep, this is x plus 4, x minus 4. Yep. Yeah, if you can't read my handwriting, please check me on that. I am terrible. I know it. All right. Let's talk domains. This is the new stuff. Okay. If my Hungarian grandmother walks up to me on the street and says, young man, Mr. Andrew, what is a domain? The plain English definition I would give her is it's what X values you're allowed to plug in. The book would tell you, in a much more formal definition, they would say the set of all real numbers for which a function is described can be referred to as the domain. So it's basically, you have the real number line, which you've been looking at since you were in kindergarten, whether you knew it or not. You have the real number line. You have all the negatives, you have all the positives, you have fractions, you have all that. And then the domain is what part of that line you're allowed to plug in. Now, in my class, and potentially in 115, if you end up taking that, if you get asked to find the domain of something, here's a trick. Find what you're not allowed to plug in. You have a question, or you just adjusting your glasses? Neat. I don't really recommend doing it with a pencil because I find you lose like fine motor control that way, but that's just me. Okay, so let's take the problem. Not even take the problem. Let's take the expression. X squared. Okay. If I look at x squared and I look at it on a graph, and that's the key. You're going to start looking at graphs in my class now. But if you look at this on a graph, it basically just looks like a U. And I'm not talking about the football team in Miami. All right, so it looks like a parabola. Now, here's the thing. If you keep zooming out, zooming out, zooming out, it'll just keep going on to the right. It'll just keep going on to the left. All right, this goes on for infinity. And this goes on to negative infinity. So what is this thing's domain? The domain of x squared, which is, this is how I write it. And spoiler, that's how a lot of people write it. You would say this is from negative infinity to infinity. You can plug in anything into x squared. If you give me any number, I can take my puny little phone calculator and I can square it. That is something I can do with any number. I can square them all. It's not terribly difficult. Now, here's another problem though. Let's say we have 1 over x. Okay, this one's tricky. First of all, graphing this, if you've never done it before, can be unpleasant. But it basically looks something like this. Okay, now here's the thing. This y-axis that you have dead middle of your graph, it will never touch. And the reason for that, here's a general rule of just math in general. You can't divide by 0. All right, it's undefined. If I take, you know, a pizza, I can divide it in 2 and give it to 2 people. If I have a pizza, I divide by 1 because I'm hungry, darn it, I'm going to eat the whole thing. I can do that. The problem is I can never actually divide a pizza for 0 people to eat it. And no, we're not counting giving it to the raccoons outside. So you can't actually divide anything by 0. If you go ahead and try on your calculator, you're going to get like error or undefined. So a general rule, anytime you see a fraction, there's an x in there, you basically just know x can't be 0. So the domain of this critter is everything except 0. So, and you can write that 2 ways. You're going to see this 2 ways. I'm going to show you both. X does not equal 0. That's one way you're going to see it. This might be called like set notation. This is the set of all things that x can't be. The other thing you're going to see it written as interval notation. That's what I did up here. This was interval notation. And now interval notation, okay, we just can't be 0. Everything else, though, is fair game. So I would say negative infinity. And by the way, you put a parenthesis on points you can't actually sit on, right? This is called an open bracket. You can never actually sit on infinity, right? There's no largest number you can sit on. So then this goes to 0. I can't sit on 0, so that gets another parenthesis. And then we're going to add this to the other part of the graph. So we're going to union it. That's a U. If I drew it better, you would see that. So then 0, now go to the right. Get all the positive stuff. Up to positive infinity, which we still can't sit on. So the domain of 1 over x, because you can't divide by 0, is just every number except 0. That's it. Questions so far about domain?
When do you have to use the same thing?
So if, okay, so with the U, anytime, so on my graph here, I have 2 chunks that I have, right? I got the positives, skip 0, I got the negatives. So anytime you have 2 chunks or more on your graph, you need to use the U to like show that this is what you're allowed to be in. So if there were 3 chunks, I would have chunk 1, union, chunk 2, union, chunk 3. Good question. Anybody else got questions about domain? How many of you have heard of domain or used it or looked at before? Okay, I'm seeing actually more hands up than anything else. Okay, great. I might not end up spending so much time on that. Great. The other thing you really have to worry about, in my class at least, for domain, is what happens with square roots. Now, you can take square root of a positive number. It might not be pretty, but you can always do it with a calculator, right? The square root of 3 isn't nice. It's like 1.7 something, but you can do it. You can take the square root of 0. That is actually legal. You can take square root of 0. It's just going to be 0. Nothing really going on there. Your problem arises, you can't take the square root of a negative number. If you take square root of a negative number, you get weird stuff. You get like imaginary numbers and stuff. Let's stick in real world right now and just go ahead and say, oh, it looks rainy out there. That is foreboding. But anyways, you can't take the square root of a negative number right now. We'll get there later, but for right now, no negative numbers in our square roots. So if we were looking at the domain of square root of x. All right. Oh, you're officially at the part of the semester where you're going to see more and more of Andrew's terrible drawings. We're getting away from my terrible handwriting. I really am sorry, but I am trying. But basically, the square root of x, if you had to graph it, the actual curve looks something like this. And it just goes up, off, and away. Very slowly, but it goes up, off, and away forever and ever and ever. This is your y-axis, this is your x-axis, yada, yada. There we go. Now I can say I did an actual graph today. Okay. Now, again, the domain of this critter is you have 0 and everything to the right of it, everything positive of it. So domain of this thing, in set notation, you would say x greater than or equal to 0, or in interval notation, you would say you go from 0, and you're allowed to sit on 0. You're allowed to take that square root up and on to infinity. Now, another thing, I just do this, but it's not just to have it. This is what you're supposed to do. You put the smaller number to the left, you put the bigger number to the right. Anytime you're doing intervals like that, it's always smaller number to bigger number. Just an FYI. I know some people have done like infinity, comma, 0, and like they put parentheses. Yeah, flip that. WebAssign growls at you if you have your intervals flipped. Just a heads up. Questions on square roots? Okay. Now let's talk briefly about, well, let's see you show of hands again. Sorry, Zoom people, I can't see your hands, but I'm imagining them. Show of hands. Who thinks they know what a rational expression is? Who would wager a guess at one if you were forced to? Not even going to make you. I'm just curious. Act of confidence. Okay, you all know what a rational expression is, whether you know it or not. A rational expression, this is the other part of today's lesson, is, well, let's look at the word. Rational, right? You know what word lives right in rational? The word ratio. And that's how you should think of them. So it's a ratio of two, the book would tell you rational expression is a ratio of two real defined functions. Okay, so you got some critter divided by another critter. Okay, neat. Now this could be just 1 over x. This could be, and this will be, x squared plus 5x plus 6, all divided by x plus 2. This is actually a problem from your homework, is what is the domain of this critter, and then simplify it. It also could be something along the lines of, oh, I don't know, x squared minus 16 all over the square root x squared minus 4. That's another one. That's kind of like what's on your homework. You know, what is the domain of this thing? Simplify it if possible. It's actually a bit disgusting to look at. But anyways, these functions are all rational expressions. There's a ratio, there's something on the top, there's something on the bottom. Anytime you hear rational expression, in the back of your head, you should be like, ratio, that's a fraction. That's wimpy lightning. Come on. Mother Nature, step it up. Let's go. Decent thunder, decent thunder. I give that like a B minus. Oh, that's the other thing too. I don't know if y'all know, but I grew up in Iowa. And I don't know if you know anything about Iowa weather, but smack dab middle of Tornado Alley. A few towns over got absolutely leveled. There's literally no building left standing by a windstorm / tornado. So I don't really get intimidated by the stuff they have up here. The snow's nice though. I like having a couple 100 inches of snow every year. That's nice. This is cute. That's a cute little light show. Anywho, so we got rational expressions. The main thing that you're going to get tested on in my class about with these is you're going to get asked simplify them, and you're going to get asked what is the domain of them. Those are the two questions you really get asked. So I'm actually going to pull this first problem, and we're going to do it that I wrote here, which is x squared plus 5x plus 6, all over x plus 2. Okay, first I want to talk about the domain of this critter. Now, the top of it, I can take any number and square it, so that's fine. I take any number and multiply by 5, so that's all fine. I take any number and add plus 6. So in the top of that fraction here, this top here, right now, infinity, negative infinity to infinity, fair game. Nothing's changed, there's no square root, nothing funny. Now the bottom of this critter, this is where things get spicy. The bottom of my fraction, I have an x plus 2. I can't have 0 in the bottom of the fraction. So what do we look at? Well, I look at this as an equation, x plus 2. I do not want this to be equal to 0. And now we need to solve for x to figure out what x can't be. Now this is really simple, but that's why it's an example. This is a simple example. If I want to undo adding by 2, I undo it by subtracting 2. That's the opposite of addition. So I say x can't be negative 2. So that's it. All my domain is, it's all of the numbers except negative 2. So for your 2 notations, this is your set notation. X can't be negative 2. For interval notation, I would go ahead and write this is negative infinity, can't sit on it, so it gets a parenthesis, to negative 2. I still can't sit on it, so that sucks. Union with, so that's the one chunk of the graph. The other chunk of the graph, negative 2 to positive infinity. And that's my domain of this whole chunk. Questions about domain? I'm going to get into simplifying here. Okay. Now, the reason when I say we, I mean me, having you factor so much is because you need a factor in order to simplify these things. So if you factor x squared plus 5x plus 6, if you do AC method, I'm just going to very quickly say this is x plus 2 times x plus 3. And this is all divided by x plus 2. Now, here's the funny thing. Simplifying fractions. You've all done it, right? If I have 25 over 10, well, that's 5 times 5 times 5 times 2. So we just get 5 halves. These are in common, so they cancel out. That's why they're the same fraction. 5 halves is the same thing as 25 over 10. We're going to do the same thing, except we're going to do it with terms that have variables in it. So I have x plus 2 times x plus 3. I'll divide by x plus 2. Cancel them bad boys out, and we get x plus 3. Now, here is the wonderful thing. Do not look at this for your domain. If you use this for your domain, you will get your questions wrong. You're going to get really frustrated really quickly. Because x plus 3, oh, that's every point. So fun fact. Actually, I'm going to show this to you. Okay. Desmos.com/calculator, great if you just want to quickly eyeball something. So y equals x plus 3. Okay. It's a line, looks like that. Pretty standard stuff. Okay. Now, equals, make a fraction, x squared plus 5x plus 6 all over x plus 2.
Mr. Midler, we're still on the paint screen.
Son of a gun. Share screen. Whole screen. How about now?
Yes, that's good. Thank you.
Heck yeah, let's go. Okay. Now, and then actually I have this thing divided by x plus 2. Okay. Divided by x plus 2. Okay. Now, if you actually go along this thing, notice it is like, hey, there is not a point at negative 2. This looks like x plus 3, but from a domain point, it's looking at x plus 2 down the bottom, and it's like, yeah, I know this is basically x plus 3, but that is screwing up your domain then. We can't have that. So you need to, for domain purposes, look at your function before you do any simplifying. Look at its domain first, and then go ahead and simplify it. So this is just a really quick demonstration of how that can be an issue. Questions about that? I'm going to do more examples, don't worry, but yeah.
The domain of the whole function was
Yeah, x not equal negative 2, and then the interval notation, you're just going from negative infinity to negative 2, union to, or negative 2, positive infinity. Yep. Anybody else? Okay. Let's look at another one. So let's borrow that one. So if I have x squared minus 16 all over square root x squared minus 4. Okay. If I look at the top, I can take any number and I can square it. I can take any number, subtract 16. The top has no impact on our domain. Good to know. Now the bottom, I know the bottom can't be 0. Also, it can't be negative because it's under a square root. So this chunk right here cannot be negative, and the whole bottom can't be 0. So we're going to solve for those. So square root x squared minus 4 cannot be 0. So we need to solve for x here to figure out what x cannot be. Now, how do you undo a square root? The opposite of taking a square root is squaring both sides. So we're going to go ahead and do that. And we get x squared minus 4. Change color. Bam. Square both sides. And we get x squared minus 4 equals 0 squared, which is 0. Okay, the opposite of subtracting 4 is adding 4. So let's do that. Plus 4 plus 4. We get x squared is not equal to 4. So now, what is the opposite of squaring both sides? Taking a square root. So we're going to do that. Now, when you take a square root, here's the tricky thing. Here's the tricky thing. When you take a square root in my class, yeah, you get x can't be 2. You also get that x can't be negative 2, right? Because negative 2 squared could make x. So anytime you're taking a square root of a number, it's positive and negative. You get both as answers. You need to check those. So x can't be either of these critters. Now, the good news is I already know I don't want anything negative in here too. So I already know that x squared minus 4, I know this has to be greater than 0. And then I do this whole thing again. So I know x has to be greater than positive negative 2. The trick here, though, is it has to be greater than 2. Because we need to satisfy both of these. And x has to be greater than negative 2. So we have all of these conditions running around. We can't be this. We have to be greater than this. It's really complex. We have a lot going on here. I don't know which ones I should do and which ones I shouldn't. Well, let's graph it. So if you graph this, actually, I'm just going to take a number line. I'm just going to basically check legal or not. That's basically what I'm going to do. Okay, now, what kind of points should we be looking at? We should be looking at the critical points of this. The critical points of this are the 2 and the negative 2. So I want to test, are those points legal? Are they illegal? And then I want to test things around them. Okay. Now, could I plug a negative 3 into this thing, and that would be in this domain? Well, let's try it. If I plug in a negative 3, so if I plug in a negative 3, and I square it, I get 9. 9 minus 4 is 5. Square root of 5, that's a fine number. So actually, this is okay. Negative 3 is okay. So let's try something else. Change the color. Okay, negative 2, is that okay? If I take negative 2 squared, minus 4, I get 4 minus 4. That's 0. I don't want 0 in the bottom of my fraction though, so that's a no-go. So no-go on negative 2. I have a space there. That's what I'm doing. When I put that empty circle in there, that's a space. You're not allowed to sit on negative 2. That gets into the whole parenthesis versus bracket thing that I was talking about earlier. Okay. Let's try something in the middle here. What's between -2 and 2? 0. Let's try 0. Can I plug in 0? Well, 0 squared minus 4 square root of -4. Oh no, can't take a square root of a negative number. That's not allowed. So this whole region is a no-go. Can't do it. Maybe you take algebra from Dr. Amy Barnsley here at NMU? No, okay. If you
Yes.
did, I was going to say, I think she's ambivalent about my notation here with like smiley faces and frowny faces, last I checked. If you have different notation you want to use for marking whether a region's good or not, great. I use frowny faces and smiley faces. That's me. Can we plug in 2? I think we decided that, but let's check again. 2 squared minus 4. 4 minus 4 is 0. Still can't do it. So this is also an empty point. We're not allowed to be there. All right, last thing. We need a point bigger than 2. Let's try 3. 3 squared minus 4. We get 9 minus 4 square root of 5. Square root of 5, that's a perfectly fine number. It's weird, you need a calculator, but perfectly fine. So this whole region's good. So I have 2 regions that are good, and the points on the ends of them, the 2 and -2, are no-goes. So for your domain, this is the last problem we're doing today. For your domain, in interval notation, so interval notation, -infinity, -2 can't sit on it, right? This whole region over here is fine. We just can't sit on -2. We're going to union that with the other chunk we're allowed, which is can't sit on 2, but anything after it up to positive infinity. Now, in set builder notation, I would say X does not live in like that region -2 to 2. Anything in there is a no-fly zone, basically. Again, I don't really care about the notation. I'm exposing you to the notations because that's what you're going to be seeing on your web assigned homework. I think I'm going to be asking for interval every time on exams and quizzes and things like that. In my quizzes, I mean written assignments, but you know what I mean. Okay, now the question that I'm going to do, and then I'm going to take attendance and get y'all out of here. Zoom kids, you're going to be done in like a minute here. But if I have x squared minus 16 all over this square root. Okay, if we're asked to simplify this now, we have the domain. Now go ahead and simplify it. Well, this up top is difference perfect squares. I get x minus 4. I get x plus 4. And this is all square root of x squared minus 4. Is there anything in common? Not quite. It's really close. This is an x minus 4. This is an x squared minus 4. So I'm afraid not. There's nothing in common here. This is simplified. So it's already in simplified form. Nothing we can do. There's no common number, no common variable. We can rip out every single term. Sad. Okay. I think I'm done lecturing on math. I'm gonna take attendance real quick because I need to fill out a new seating chart. So basically, I'm gonna be calling on all of you. Any math questions? Yeah. Oh yeah, we knew that, but I was just showing that, hey, if you're like ever like doubting yourself, go ahead and test it again. You can always test it. You can always reaffirm that. Not really. All right. You can't minimize Zoom while you're recording. Yeah. Shush. Okay. Actually, Abigail, right? Yes. Oh shoot. Huh? Jared. Husky, right? Yes. Okay, I have that at least. I actually have the last name. I can't get the first name. Caleb? No, terrible. What you got? Jacob. Jared and Jacob. Ooh, that's gonna be rough. Okay. Should have had that. I should have tried. Nope. What you got? Carlos. You prefer Joseph or Joe? Joseph.
I'm here.
There it is. If there's ever an infinity gauntlet on Earth, I'm going to be the only person that can snap it.
Yeah.
I'm Maya, but like, I'm not supposed to be here.
Okay, at this point, do you want to be here?
I'd rather go tomorrow.
Okay, great. You don't exist on my scene chart.
Ryden.
One more time.
Ryden.
Spell.
R-Y-V-E-N.
Okay, that is it. Okay, great. You're all set to go. Any questions, homework, anything else? Okay, written assignment. Remember, that's due Friday, noon. I actually think it's easier than the web assignment this week. So, yay. What else?
It's Monday and Wednesday, right? Oops.
So there's the Monday, Wednesday group and the Tuesday, Thursday.
Okay, sorry.
You're here Wednesday, so you're gonna be here Monday.
Yeah, okay. That's what I thought.
Yeah.
Another question about the first homework that's due this week, and
We like the web assign or?
yeah, the web design.
Yeah. What's up?
So, like the difference of squares, I get the main point of it, and like you have your A and your B term.
Okay.
Does the B always have to be just a regular number, or can that be
It can have other stuff.
the chunk with the X in it?
Yep,
also?
it's a chunk,
Yeah.
right? So you have an A chunk and you have a B chunk, and they might be a bit complex, right? Because that was the first problem we did. We had the X squared plus 8 chunk. So it can be a whole complicated chunk squared minus a chunk squared.
Okay, so when you